Nothing we can do about it, damn kid. Oh, hey, Jordan, how we doing?
Doing good, Adam. How are you?
I'm doing well. Jordan, we got a pretty exciting one today.
Yes, we do.
What are we doing?
We are taking a tour on the manufacturing and how we build modules here in the States.
Look at that. The Patriot, our first American-made module. I wore it. I wore my principal.
Look at you, repping.
Made in the USA shirt. It actually says made in St. Angelo, which I wasn't. I'm a little north of there, but this is going to be good. So we're gonna navigate through multiple parts of the facility, right?
Yes, we are.
You know where we're headed today, or what?
Yeah, we're going over to manufacturing. We're going to visit with Sean first off, and then just move forward from there.
Oh, very awesome. All right, well, you let me know when you're ready. Kick it off. You know where we're heading first.
All right. Look at him. Hey, Sean.
We ready? Hey, how y'all doing? Can y'all hear me okay?
Doing good. We are ready.
Good. All right. Well, let's start with a picture of manufacturing. We'll give you a whole shot of everything we have here. And then we'll start in the SMT room, which is right over here. So we'll take a short walk into there.
And Sean, what is the SMT room? What does SMT stand for?
SMT stands for Surface Mount Technology, is what it stands for. Basically, we take a bare board and place components on the board to complete a circuit to do whatever it is we desire it to do. In this case, light up a LED. So we'll start, you see all of our components, and everything in a gray bag here is a moisture barrier bag. So everything is sealed up, the LEDs when they come in, and we open them up here and we run stuff. So we have several different colors of LEDs. CCT levels that we can place on any given quantity that we want to build. So we have our LEDs basically in these bags. You see our resistors and sights and other components that we place on the board. And a bare board, when we run one, we just have a panel. There's nothing on this panel. And we place the solder paste through our stencil, and we place all these components on this panel. We can place this panel in roughly 18 seconds complete through our process.
Wow.
Hey, Sean.
So,
Real quick.
Yes.
How many modules is on that board?
100. There's 100 modules on this panel.
Wow. So we're making 100 modules there. And those bags you touched before, those are just giant reels of LED diodes?
Correct. LEDs. I'll grab one and give you a little better look at it. So we have one here, obviously outside of the bag because we ran this recently. But this reel has like 16,000 LEDs, the little yellow things.
Oh, wow.
That you can see right there. And the CCT level of this, if I can read this properly, is I want to say like 27. Well, actually, here's the part number. It's 4,000 is what the CCT level is.
For all of our warm white customers out there, we've got a nice 4,000.
There you go.
That's actually quite a bit of inventory you got right there, just 16,000 plus on a reel.
Yes, per reel, absolutely. And we can run quite a bit through here. So actually, yeah, these two racks and then our machines. So basically, our first machine, we put solder paste on through our stencils and put it on the apertures. The next machine we have, the next two, actually pick the parts and place them. You can see everything's already preloaded. So when we get ready to change from one assembly to the next assembly, all we do is change the program and we go. There's no big changeover from one to the other or downtime. Same with our oven, we just change the program and go and the rails if we need to. And all the LEDs are preloaded here. So this is basically all 6500, mainly 6500. We have a different, you see the different colors of LEDs. And I think this one right here is a 2700 color LED right there.
Wow.
This room, some things that you don't see, I don't know if y'all see it on Neil, is the floor. The floor is the ESD floor, ESD epoxy floor. So the people who work in here, including myself and Eric, we have ESD shoes. So these boots are still total ESD, allowing the static in our bodies to dissipate through the floor so we can help protect our product. We also have it temperature controlled, humidity controlled in this room to reduce the amount of static that's in the air. So once it comes through, and again, we can build that panel in 18, 20 seconds. Once we fill up this oven, this is basically where all the magic happens, is in this oven. This oven gets up to 270 C, is what we have the recipe set to. The reason why is because the solder paste that we put on that actually holds the parts through the process goes from a paste to a liquid to a solid. That's what solders all the parts on the board or that panel at one time. And basically that's about right here. That's where that happens. And then it goes solid on the other end. So we have solid. After everything is built, we have some inventory in house, some things we want to show you. I don't know if you see. All of our boards are aluminum substrate on the back. This allows us to take the heat from the LED, pass it through the board to our substrate to get it away. Extends the life of the LED.
And all those boards up there, Sean, those are boards of 100 LEDs each board?
Well, these are heavyweight. No, these are 40 boards per panel. Excuse me, 30 boards per panel. If I have Patriot, QM2, QM3, everyone is a little bit different. I don't have a Patriot built here in the room. I have them outside though. You got Patriot there? This is 100 boards. So
okay, so that's the
we have a
Patriot.
resistor.
So each board back there is a different product of LEDs that we're actually picking, placing, and putting together in San Angelo, Texas.
Absolutely. And we have some inventory, some safety stock inside this room that we keep here, and we keep stuff out on the floor. We'll show you here in a minute. By the way, this is Eric. You'll be talking to him here in a minute.
Hey, Eric.
He has his ESD shoes on too. So this is stuff inside the room. Also in this room, before the product leaves this room, we actually do a quality check, or ICT, which is in-circuit testing. So everything 100% comes to this room. We have a fixture, kind of a bed of nails. We'll take a panel and put it on there. And what this does is once we hit start, it lights up all the LEDs and it tests the components. It tests the LED components, and it does it in 4.4 seconds. Comes up green for pass, or if it fails, it'll come up red. So we do have stuff that comes up red for whatever reason. Could be the board or a component. And we catch that stuff here before it gets out into our manufacturing process. It kind of helps us.
That's pretty incredible. So, Sean, we're not only just making this product, but we're actually doing all the quality control and testing in-house.
Yes.
So, Sean, you mentioned that you could pull together a board in about 18 seconds. What would be the time to run all the way through that line?
All the way through the line, roughly 20 minutes, because it has to go through each process. So the pick and place can place it in 18 seconds, but it still has to travel through the conveyor, through the oven. It takes a good 6 to 8 minutes to get through the oven. So once everything is full, though, once all the conveyors are full and the oven's full, we can drop a panel off the end of that oven every 18 to 20 seconds. It'll come off the end of it.
That's pretty cool.
So that's a panel of 100 or a panel of 30 or 40 coming off the end of that oven every 20 seconds.
Every 20 seconds. Jordan, that's a lot of LEDs.
Yes.
I hope people are watching. We got to move some LEDs now.
Yes. All right.
What are we looking at now here, Sean? Oh, he left us. Jordan, where are we headed next? That's pretty incredible, right?
Yeah.
Every 18 seconds, 100 plus LEDs back into that rotation and pumped out.
Yeah, it's insane. And I think it's cool too, the Kelvin temperatures, just like that reel of LEDs that was 4,000 K. You know, we can make every request custom, and there's really not even a custom. We can build it.
Right. What might be custom is not custom to us.
Right.
Because of the inventory we have. You're right. He goes 2,700, 4,000. We had Street Fighter back there. And then we, of course, had Patriot he was looking at and some different products.
Quick mod. Yep.
So, Jordan, we run through this. Where are we headed next and who we talking to?
Good. I think we're going to the robotic soldering.
Okay. With Eric, right?
Yes.
All right. Let's go find Eric or Sean. Whoever's next.
Yeah.
one of the two. John, we're back with you.
Okay, so we're here at our wire cutting machine at robotic soldering. So basically, we take wires out of the barrels. We strip them to length. We put flux on them and tune them. and get them ready to be robotic soldered.
Hey, Sean, can you kind of explain what the soldering helps with and the flux?
Sure, you bet. So we put the flux on. I'm gonna go ahead and stop this real quick. So we put the flux on to let the solder wick, or actually wet. It'll clean the wire and let the solder actually flow up to the deal. It keeps the strands of this wire together, so when we solder them, they don't spray out and they don't go all over the place. That's why we tin this stuff.
I mean, that thing's moving pretty quick too, Sean. What's the goal on a machine like that?
I'm sorry, what was that question?
So, Sean, that's moving pretty quick. What's the output of something like that for our production wise? What are we looking to produce in a day?
It depends on the length of the wire. Obviously, there's variables to go into it, but give you a rough estimate, we can put out roughly 10,000 of these things a day in a shift. And that's your ballpark. So 10,000 of these things a shift.
Wow.
So we're going over to our robotic solder machines now. Unless you have any more questions about the wire cutting machine.
No, you did well. Right, Jordan? We don't have any more questions on that one.
No, I'm good.
Okay. So basically, this is Kat. This is our operator, and she's doing robotic soldering. And this is how we take those wires and actually solder them to the board. Can y'all see that pretty good?
Yeah, we can.
Yeah. So Sean, one of those funnels in the actual the solder, and then the other one heats it up onto the board. Correct.
Yeah, correct. Absolutely correct. Let's see. I'm sorry. So yeah, basically that is our solder tip right there. That's at 440C, and that's our solder wire right there that feeds down into it. That creates that solder connection. So basically what Kat does here, she loads these wires into our wire cover or lid, and then moves that stuff over. Actually, she's fixing to do a process. We'll just hang out here for another few seconds and watch what she does. And this is how this is a column of 10. So she basically takes, over here to the right, you see the finished product, all these boards. This is all finished product of varying assemblies. And she'll get what she needs. She'll put it on her ESD tote, stand on her ESD mat, get a column that she has, verify that it's the right stuff. We also print on the back of these things the P-lead, the CCT level, and of course the date that this was built. Make sure it's right, and then watch her. Here she goes.
So, Sean, this is the process of completing the strand of modules, for example. So it's one LED with the wire to the next LED.
Yes,
am I correct? Okay.
And
so that spacing will change based on the product we're creating?
Yes, true.
And she's just making sure that the 10. Oh, go ahead.
Yeah, well, yeah, she's making sure that it doesn't overlay the land, because if it sticks over too far, it can get in the way of the lens in the next process step. Eric can cover that. But she's making sure it lines up perfectly, so when she starts the machine up again, it's where it needs to be. Because in the lids, the wire will slide a little bit.
That's pretty awesome.
Yeah.
And back to work, and it's all robotic and automated, and that's very, very cool.
Yeah, and repeatable. That's a big deal. It's a process that is repeatable.
Right. What I like about that is that you got the hands-on person in Texas making sure that that's lined up properly, that everything's done right, so you're not just finding out the end of a run, or somewhere along the line the equipment might have screwed up. You've got a hands-on person at each one of these stations taking care of what's going on.
Yes, correct. And actually on the next robotic station over here, this one's already completed some strings. So actually Ian guards this, so he tapes it up, puts the date and machine that he was on. So this is completed. So This is Patriot, which is about 22 columns of these modules, and this goes over to our inspection station. So everything's 100% visually inspected as well before it goes to the next station, and make sure the solder connection is good. And if the wire is there, it's the right wire.
That's awesome.
And
That's
we
the
have
Patriot.
basically 10.
Go ahead, I'm
Well,
sorry,
yeah,
sir.
this is Patriot.
It's our 24
Patriot
volt
medium
American
is
made
what this
module.
Yes,
Yes.
it is. Right here.
All right,
So
Sean. I
that
think
is robotic soldering.
yeah,
Go
I
ahead.
think Jordan and I are going to jump over to the next station. We'll see you in a little bit. Thank you, Sean.
Thank
Okay,
you.
good. Oh, you bet.
Thank you for everything you do.
Yeah, that's pretty cool. So yeah,
I saw just myself for a moment. I thought she wanted a close up of the shirt. Well,
that is a sweet shirt.
We've got people from all over watching. I see Alaska on there, Orlando, Southern California.
There we go. Getting
Some random guy from Iowa.
Ah,
So we got some good people. I mean, the greatest thing I think we're watching, and we have three more really little departments we're going to jump to, is that we're watching it go from a diode on a reel, a circuit board that's raw, how it gets made, how fast, right? 16,000 diodes on that reel. We can do every 18 seconds, another 140 panels, shot out the door, comes over to where Kat was in the robotic soldering. A human picks that up, puts it down, and she physically checks all those details, lays it in, and they just get pumped. They get reeled. And what we saw was an LED on the wire taped up in a reel. And now we need to put it into a mold and begin that process. So where are we headed?
we're headed to injection molding.
Boom. We're going to be with Eric, right?
Yes, Eric is gonna go over that process with us.
All right, let's go find him. We should tell him to turn the lights on.
Yeah, Eric, you there?
There we go. Well, it's not Eric, but we're back there.
Getting
There we
close.
go. Hey, Eric, can you hear us?
Hey, we're having.
Hey, Eric.
Eric, I don't think they can hear you. Try putting this back in.
He must not. He's okay with the mask, but he's not a headphone guy.
There you go.
Well, we'll jump right back to him, but we can see we'll be good back there. So we're going to do injection molding. This is where, when he was saying she goes on and checks to make sure the wires don't slip into that mold or that lens.
Yeah.
So this will be then that forming that actual footprint. So we're ready whenever. I guess the people who push the buttons are in control already.
Can y'all hear me now?
All right,
Yeah,
there you go, Eric.
We got you.
Eric, so we're
All right. Hey, thanks.
how you doing?
So we are here at our injection molding. This is where we take place with finishing our robotic soldering, our next step. So basically, this is where we'll take our mods and we'll actually mold our plastic with our lens. And this is where we kind of help solidify with get our IP67 and 68 ratings and all that good stuff. So this is where our precision comes into place with our placements of our lenses and our wires. Oh, sorry. So this is where we have a little bit of our heavy machinery coming across. So as you can see from our components, from our finished product, from one side to the other. So this is where our finish comes through. Take our screw off. This is where our runners are. And so basically this is.
Hey, Eric. So how is
Yes.
the? Can you show how the actual molding is like processed there? How does it filter down, and just how does
So it
that
filters
kind of
down,
work
yes.
into the machine?
Or if you want to kind of span back to the machine itself. So what we have is we actually have our ABS components. We've kind of narrowed down to just one type of plastic. We had at the beginning of our process, we had two different plastics. We had our ABS and we also had our PVC, yes. So now we narrowed it down just to our ABS, which is more durable. It's a little bit easier to mold with. So our machine here basically takes our our pellets of plastic that we have in this hopper, and basically it slowly feeds it down into our heater. So basically this heater screw right here basically actually slowly but surely gets that stuff hot enough to where it actually melts.
Okay.
Right now we're set at 240 degrees Celsius at a final stage here. So it goes from 220 down to 240 at our nozzle. If we can get we'll get a little sample here. So it's slow but surely, so it doesn't basically burn. So basically it's slowly but surely, just like you would any kind of in an oven. You want that thing slowly but surely to come up to temperature, so we don't have any kind of process that
Cracks or anything like that. Yeah.
And Eric, you're making a Street Fighter module there?
This is our Street Fighter heavyweight right here.
Okay.
Oh, cool.
And so what's good about this, with all our machines that we have 14 injection molding machines. This really helps to diversify with what we can get out, and kind of helps with the demand. We kind of help match the demand that's upon us. So basically, if we have a high run of Patriot, or if we have a high run of standard, whatever it is, QM2, QM3s, we have the ability to change machines around, and all it takes is basically, they're all the same machine. We just have different molds for different products.
So
Pretty cool.
that spot where you actually place the board in, he's placing the board in, he's putting the lens over it, and that's a jig that he's setting that in, correct?
Yes, yeah, that's what we call our mold. So basically,
Oh, mold.
that
Gotcha.
mold is cut into two different halves. So basically, that thing comes together. When it comes down together like it is now, from this nozzle right above that, it's actually shooting that melted plastic through there and filling that cavity up all around our lens and our module. So here's kind of here's what that plastic looks like before it goes into the machine. So it's just a bunch of pellets of plastic, and it kind of helps melt whenever it does come down through that chute. And again, kind of like with our SMT room, this stuff, it really needs to be controlled. So basically, any kind of moisture that gets in there, we have to get that stuff out. So we have our ABS prior to going into our hopper above. We actually have a dryer and a dehumidifier. Basically, it takes all the moisture out of that thing, heats those things up to roughly about 175 degrees Celsius. So that's our
Nice.
dryer and dehumidifier, basically.
Oh,
Because
cool.
any kind of moisture, it's just like anything. Like you put like if you have a pan of grease on the stove, and you put any kind of moisture or water in there, how it bubbles and cracks, it does the same thing. So we got to keep that stuff as dry as possible. So
That's awesome.
Cool.
All right, so we got a mold. We've got a chip to a board, soldered. We got molding. Eric, I think we're going to meet you somewhere else in a little bit. Thank you for taking us through the
Perfect.
injection molding.
okay, great.
All right, so Jordan, obviously, many people out there watching, a lot of people always think Patriot is the American-made product. We're watching a lot of Street Fighter on there. He talked about Quick Mod. We're doing a lot of value add and assembly here. But I think what's kind of most important is going to be these last two steps, right? It's one thing to say you can do it, and a lot of our competitors and other companies might bring in LEDs, and they might have them tested by third parties or bring them in. But here we're making it and checking it every step of the way. I think we're jumping over to field inspection and packaging, right?
Correct.
And
Yeah,
we're
so
going to join Eric again. Any remarks on anything before we jump over to Eric?
Nope. I was just gonna say, yeah, we're doing another inspection. There's a lot of inspections just to make sure everything's running smooth through this whole process.
We don't like to take them back.
No.
We want to make sure they go out there and light up. Let's jump over to field inspection and packaging with Eric.
Perfect. All right. So here we're in our final inspection and packaging. Like they said earlier, we're talking about we inspect. So SMT, of course, we have our visual and component inspection after our robotic soldering. We also have that inspection as well to make sure all our solder points are good to go. So now after our injection molding, this is kind of our final stages prior to packaging and bagging. So You can see here we have our, looks like we're running some more Street Fighter Heavyweight, is that correct? And so this is where they'll actually inspect and make sure that everything's got the correct number of modules, the wire length in between, also to make sure that everything lights up and everything's within spec on their voltage and wattage.
So Eric, when you said
it
you guys actually plug these into a power source and give them a check as well to make sure they're lit up again. I know you do this
yes.
multiple times through the process, but you're going to light them up again here at the end.
So yeah, each strand gets lit up again to make sure that there's no wire connections that were lost in the injection molding, because sometimes there is failures with popping the wires off whenever they're putting that thing into the mold, and so this is where we find that process indicator basically, and then we can go back and repair that before it gets redone. Like I say, anything that's found out here after the molding, actually we can actually cut those things out and we can actually rework those things still, so it's still not a lost cause for that whole strand, so we still have time to save that. So she'll light this thing up here in a second so she can actually test and make sure everything is up to par. So you want to look at the power supply here. So we have our power supply, then we have our amperage, and we've got a plus and minus 10%, so everything's good to go.
Oh, this way you can make sure if there was ever a voltage change or amperage change out there, the product is going to be able to withstand.
If that amperage, yes, it's correct. So if there's an amperage change there, you can actually see if there was something missing. So basically, if we're missing a module or two, which is very rarely, but if one of them is out, not only can you visually see that, but you can also sit on the amperage on the power supply as well.
Hey Jordan, thankfully these things lit up, right? We're live. We didn't.
I know.
I was. No, I'm just kidding. We knew they would light up, but
yeah, they're gonna.
So yeah,
we would have had to try. I don't know if we could edit
here,
it out if it didn't work.
So after the testing portion. So after testing, we come back over and we actually what we call kind of board these up. So these get us prepped for our taping and our printing. So here we actually put these into our boards. You can see where everything is lined up. Go ahead. So they'll put this, that'll be one single strand on each one of these boards. So like you say with our Patriots, so we have a different jig or a different board for each one of our components. And then on that last step that she just did, that Joan just had, was our primer. So we actually put a primer on this thing before we put our tape. So that helps that adhesive from that tape actually adhere and stick to our components much better than just using the adhesive by itself on that tape.
A little adhesion promoter, and there's something really cool that a lot of customers compliment us all the time about our tape. We do the a little extra with the quick release tab. I mean, customers love that. Our especially the guys and ladies in the shop that are populating cabinets, they always compliment how quick this tape comes off compared to other modules. Well, not the tape, the masking on the tape.
Yeah. So with that last clip there with Ryan, he was actually adhering our adhesive or our tape onto that thing. So basically, let's see, we got one almost ready. So we'll actually still adhere that tape on there, and they'll actually put that pressure with that roller on there to actually adhere that primer with so to really adhere that bond between our adhesive around tape, our primer, and our module itself. So that last step, you can kind of see on the back side of these, we run it through our printer, and you can see here where it's printing our date code and then our Kelvin temperature right behind that. Oh, nice. So there's never any question on when it was made or what type of material you have in your hand. With our Street Fighter product, we have in our mold, we actually have it labeled on the front so you can see what type of product it is, and on the back side you can see your different your Kelvin temperatures and your date code. So Ryan takes a run another one through our printer, and we can kind of get a close up of that.
Yeah, I think that's really big to be able to see what the Kelvin temperature of a module is, because you may have these modules loosely without a bag and not know what the actual Kelvin temperature is, and you may have several different types.
Correct.
Same with the date code identifier. That's a big deal too.
Yes.
We obviously a
Yes.
principle having a 10-year warranty for our parts and a 5-year labor. It's important to know when that LED was made, if anything were to ever happen.
Right.
And yes,
There you go. Now it's in a bag. You can call and order right now. Call your local distributor and order right now. Yeah, I like his T-shirt, dude. A nice shirt he's got there.
Awesome.
All right. Let's thank you, Eric.
Yeah, appreciate it.
I knew we were going to see different parts, but in the order that this was laid out, and I give a lot of credit, obviously, to Lauren and Ellen pulling this together, but we watched it go from a yellow dot to a full-blown module.
Yes. Yeah. It's really cool to see the whole process and how it works. And
where do we do it all?
here in the USA, there you go.
Well, we got one thing left, right? We've got them in bags. Talk about our product. We tested them multiple times, but we're going to go join Derek over in quality control.
Yes.
That should be a good one. I think we are, at least. Anyway, here we go.
There we go.
Hey, Derek, how you doing?
Hey, Derek. Can you hear us?
All right. Can you hear me? How are you? Yes.
All right.
Yep.
So it is live. And these guys are doing jobs. So we're going to jump back to Derek in a second here. We'll see him pop back up. Derek is going to run through quality control. Derek wears a lot of hats, Jordan, right? He does a lot of things here.
Yes. Yeah. So he mainly does UL. He handles all our UL stuff, and he also works with manufacturing and the quality control process as well. Trying to think of something else.
He also answers all of my calls when I call and just ask him random questions.
He does do a lot of RGB questions.
Yes.
Just not a lot with RGB.
That's awesome. Let's see if
And
we're
also-
ready. Oh, go ahead.
Also, any viewers, if you have any questions, please post them. We'll be happy to answer them. Or if we catch them in a certain area, which we've already been through most of them, please leave us a comment.
I do see a good one from Jonah here. Doesn't get any better. All made in the U.S. We got a couple on there. Got our buddy Todd Dornecker coming in with the good stuff.
There we go.
That's awesome. I'm glad to see a bunch of people on there. All right, Derek, we ready?
There he is.
Think so? Hear me?
You're a little quiet, but we're with you.
Okay. So we're sitting in quality control, and we've got a few machines just to show you real quick that we use throughout the manufacturing process, both right after SMT to make sure everything is up to spec, and then right after we bag it to make sure that during the process nothing happened and that it stays in spec. Big board right here is our integrating sphere. And all you can do with this is those LM79 tests that everybody loves so much. This is what makes them. Stick the module in on the platform, close it up, and then after you hit go on the computer screen here, it spits out everything from your Kelvin temperature, your intensity, efficiency, voltage, wattage, all that good stuff. And then at the beginning of the process, when we're testing, make sure other specs such as the spread from the lens and the beam angle are all correct. We have to go yonder.
So, Derek,
Get the module inside, hit go.
So Derek, are you doing one? Are you doing a module after it's made, or are you doing the module while it's on a circuit board? How are you testing them? Is it taking a module right off the assembly line and putting a molded module in one of these machines, or is it just the diode on a board?
We hit them in a couple different places. We'll do it right after, right before it goes into overmolding. Right
Okay.
after it comes off SMT, and then after we're done with the overmold process itself, that'll be the last time it goes into the machine. The reason being, no one wants to get a whole bunch of bags with finished product with whole lot of bobs cut off and soldered back on. So we try to make sure that the finished product doesn't have a whole bunch of cuts and splices. But do know that if you happen to open your bag and you've got one slice at the very end of the strand, it's because that's the bag that was picked that hour to do the Q. And they are picked every hour. Our guys out in the QC department, which is Danny, Terrence, and John, they go to robotic soldering, rework, most of the moment, and bagging once an hour, and we pull one bag from every product at that time. So if all we're making that day is Patriot, they're just grabbing Patriot. But if we're running 3 different modules at that point, they're going to grab all 3 every hour to make sure that everything stays consistent throughout this process.
Right. We're hearing most of it. We got a little background noise going on in that area, but basically because we do this here, that means all of those facts that we print on the bottom of our spec sheet and put on our website are facts that we've truly tested and we can stand by because we've done them in-house, not a third party.
Correct. We do have the option to send it out to the third party as always, and we feel that's still important because that's great that we have all this testing equipment and we use it to hold itself accountable. But more than anything, those third party tests make sure that you can trust that it's accurate because we're sending it to someone that's associated with us to confirm that what we're seeing is what they're seeing.
Awesome. And we got Todd Dornacker there, put up a message. He said the integrating sphere allows us to compare actual data from our products and some of our competitors. Todd's absolutely right. Somebody prints something, we're certainly going to challenge it and see what it looks like. And a lot of times we find out great information at PLED.
Yeah.
Hey, Derek, is there anything else we want to share? Otherwise, I think we're going to jump to another room and we can certainly bring you back on, but we're getting a little bit of background noise in this one. So we might just jump out of here and come back. Derek, thank you for your help. All right. Obviously, an awesome room. The background noise, I don't know if you were getting it on your end.
Yeah, I was.
I was wondering if somebody was eating chips in the background.
Yeah.
But you got the visual of it. And another step, we're doing more. What I think is most important, and I mentioned it back there, but everything we put on our data sheet and our spec sheets, we can say we 100% know because we do that. We test it here in that beautiful country right there.
Yeah, and one thing I'm sure Derek was going to go over was, we test the temperature that these are going to be operating in. We've got ovens, we've got freezers. They all hit those certain temperatures just to make sure, if you send some modules in a sign up north, it's going to be a lot colder than it is down here in Texas, and vice versa. It gets pretty warm down here, so we want to test them at those extreme temperatures to make sure they operate normal. Yeah,
absolutely. And I like that you can get the lens out of it, you get everything else out of it. I do see, thank you, Colleen. Colleen was out of Orlando, impressive quality control. She used to work at a company that's a stickler for quality. So it's definitely a compliment hearing that from Colleen. Thank you. We will, Matt Smith brought up, are we going to see some stick assembly? I think we're going to force Matt to stay tuned every Thursday at 1 o'clock until we see stick assembly, so we can kind of keep him on the reel and keep him watching.
Agreed.
We covered a lot. For anyone who caught this late, please go back and watch it. We went from the surface mount technology to robotic soldering, injection molding, field inspection and packaging. And we just finished with Derek in the quality control, where we do another layer of testing off the assembly line. Everything else we saw testing while the product was being made. Derek does the testing kind of off the line, which is incredible because that's what gives us our facts. That's what gives us our details. So very, very cool.
Yeah.
Jordan, we got to talk about one more thing here so we can keep Lauren happy.
Photo contest.
We got a photo contest. We have till September 8th. Please send your drawings, your awesome pictures, and finished signs. We had 2 guys on last week. You remember Hunter from Hardman Stein and Randy from ABS in Wildwood, New Jersey. They showed us a collage of incredible signs they did with Principal. If you're building an awesome sign, which you are, and you're using Principal, which we hope you are, especially now that you've watched this American-made product with the quality, submit your photos, win $500, $300 for second place, and $200 for third place. We have till September 8th for the United We Shine Principal LED photo contest here. Jordan, any last words on our awesome plant tour today?
No, but like you said, stay tuned. Hope to see y'all all on Thursday, and y'all stay safe out there.
Thursday, 1 o'clock Eastern, 12 o'clock, 11 and 10 for everybody else, right?
Yeah.
Well, 1 o'clock Eastern every Thursday. We'll be back and we'll go dive deeper and deeper into Principal every Thursday. Thank you, everybody, for watching, and hope you have a great rest of your week.
See y'all.